In this video, I want to talk about some temperature scales. So the three most temperature scales are Fahrenheit, Celsius, and Kelvin. So Fahrenheit is the first one. This is probably the one that you're most familiar with. It's what we use in the US. And then Celsius, scale that most everyone else uses. And then Kelvin, which is used in the sciences. So if we're thinking about what temperature water freezes at on the three different scales, for Fahrenheit it's 32 degrees Fahrenheit, for Celsius it's 0 degrees Fahrenheit, and for Kelvin it's 273 kelvins. And then let's do what temperature water boils at. So Fahrenheit 212 degrees Fahrenheit, Celsius 100 degrees Celsius, and Kelvin 373 kelvins. The Kelvin scale is also called the absolute scale because Kelvin temperatures can never be negative. The lowest Kelvin temperature is 0 kelvins, which corresponds to negative 273 degrees Celsius. Here we have the three scales again, so Fahrenheit, Celsius, Kelvin, and they're in ice water and then boiling water. So the delta T, or the difference in T, so here to here, if we're talking about the change in temperature when we're dealing with Fahrenheit, there's a delta T of 180 degrees, or basically you can think of it as 180 little divisions between ice water and boiling water, so freezing and boiling. In Celsius, there's 100 degrees change. Then in Kelvin, there's 100 degrees change. So the Kelvin scale and the Celsius scale, they're just shifted from one another. So if you say that you've increased the temperature by 2 degrees Celsius, that's the same as saying you've increased by 2 Kelvin. Now with Fahrenheit, it's different. If you increased by 2 degrees Fahrenheit, that's different than 2 degrees Celsius. An increase in 2 degrees Fahrenheit is less of an increase than 2 degrees Celsius. It's important to know how to convert between the different temperature scales. Now let's say we want to convert into Celsius from Fahrenheit. So in order to get degrees Celsius, we take the temperature in Fahrenheit, I'll just do T sub F, we're going to subtract 32, and then we're going to divide by 1.8. So this is an equation that you're definitely going to want to know. Now we could go the opposite way, so we want to get Fahrenheit from Celsius. Now let me just show you how we would manipulate this first equation here. So what we would do is we'd move this up, so we'd have degrees Celsius times 1.8, and that would be gone now. So that equals temperature in Fahrenheit minus 32. And then we would add 32 to both sides. And that would get us just Fahrenheit temperature equals degrees Celsius times 1.8. We'll put that in parentheses, plus 32. So you really don't have to remember both of these equations. They're the same thing, just whichever form is easier for you to remember. Now the next conversion, Celsius to Kelvin. If we want to get into Kelvin from Celsius, we just take degrees Celsius and we add 273. Pretty simple equation. Now if we want to go opposite, let's say we want to get into Celsius and we have kelvins, we'll just rearrange this equation. Those cancel. So we get degrees Celsius equals kelvins minus 273. And that's probably the most common conversion are these two right here, Celsius to kelvins or vice versa. Now, if we want to go Fahrenheit to Kelvin, first thing we should do is we should go Fahrenheit to degrees Celsius. So we should do this equation right here, our first one. And then we want to go Celsius to Kelvin, so we're going to add 273 to that equation there. And then opposite, if we want to go Kelvin to Fahrenheit, the first thing we should do is get into degrees Celsius and then convert into Fahrenheit. All right, first example problem. The average high temperature in the month of June in Lubbock is 91 degrees Fahrenheit. What is this in Celsius? Now, let's just say that I really like this equation here. Fahrenheit equals 1.8 Celsius plus 32. But I want to get Celsius. So the way we'd rearrange this is we'd subtract 32. That would cancel. We get Fahrenheit minus 32 equals 1.8 Celsius. And then we divide by 1.8. And we'd get Celsius equals Fahrenheit minus 32 divided by 1.8. So you can see how you can just rearrange the equation there. Alright, so Celsius equals 91 degrees Fahrenheit minus 32 divided by 1.8. So that would be 59 divided by 1.8. So we would get 33 degrees Celsius. Alright, second example. The temperature at the equator of Mars can drop to negative 75 degrees Celsius at night. What is this in kelvins? So, an equation for kelvins is kelvins equals Celsius plus 273. So this is negative 75 plus 273, which equals 198 kelvins. Now, just be really careful with this. It's a pretty simple equation, but make sure you're adding and subtracting in the right spots. So when you're going from Celsius to Kelvin, you're adding the 273. The opposite way, Kelvin to Celsius, you're subtracting 273. So if you ever come up with a Kelvin temperature that is negative, you know something went wrong in your calculation. Because remember, the Kelvin scale is the absolute scale. The lowest possible temperature is 0 kelvins. Next example, the metal gallium melts at about 86 degrees Fahrenheit. What is this in kelvins? Okay, so we want to go, first of all, from Fahrenheit to Celsius, and then we want to go into kelvins. So we need to know an equation going from Fahrenheit to Celsius. So we have Celsius equals Fahrenheit minus 32 over 1.8. So here's our first step. So we do 86 minus 32 over 1.8 equals 30 degrees Celsius. And then we want to get into kelvins. So we know that kelvins is Celsius plus 273. So it's 30 plus 273. So 303 kelvins. Okay, so a few practice problems. So go ahead and try these on your own and then come back to the video once you think you have all the answers and see if you got them correct. Okay, first question. So we have 3 different temperatures here and we want to rank them from lowest to highest. But the issue is they're in different units. One's in Fahrenheit, one's in Celsius, one's in Kelvin. So we can't just rank them from smallest number to largest number. What I would recommend doing is converting these all into the same scale. So why don't we convert everything into Celsius? Alright, so convert 201 degrees Fahrenheit into Celsius. You should get about 93.9 degrees Celsius. Obviously B we don't have to do anything to because it's already in Celsius. And then kelvins to Celsius, we're going to subtract 273, so we get negative 48 degrees Celsius. So now we look at these 3 numbers here and we can rank them. So obviously negative 48 is the smallest. So C is the lowest temperature. And then 93.9 is the next, so A. And then the highest temperature is B, 105 degrees Celsius. Alright, problem number 2. A sample of ethanol is at 225 kelvins. The freezing point of ethanol is about negative 114 degrees Celsius and the boiling point is at about 78 degrees Celsius. We want to know, is this particular sample solid, liquid, or gas? Okay, so what I would recommend doing is just draw out a scale real quick. So negative 114 degrees Celsius, 78 degrees Celsius. So if it's below 114, it's solid. If it's between negative 114. If it's between negative 114 and 78, it's liquid. And if it's above 78, it's gas. So we want to figure out where does this 225 kelvins fall at. And it's not over here because it's 225, because we have different units. We have Celsius and Kelvin. So we have to convert 225 Kelvin into Celsius. So degrees Celsius equals Kelvin minus 273. So we get degrees Celsius equal to negative 48. So that means it's somewhere in here. It's somewhere between the negative 114 and 78. So that means our sample would be liquid. All right, final one. Which of the following represents the greatest change in temperature? Now, the issue with this here is they all have a 10-degree change, but we're dealing with 3 different scales. So we know that the Celsius and Kelvin scales, the temperature change, when you're calculating a temperature change, it's the same on both scales. But with the Fahrenheit, we know that if we change 1 degree Fahrenheit, that's less of a change than 1 degree Celsius. So if we change 10 degrees Fahrenheit, that's less of a change than changing 10 degrees Celsius or 10 degrees Kelvin. So the greatest change would actually be a tie between B and C.